our subsystems in the aquaponic in general are power supply, water supply, cooling, and we are also doing monitoring for temperature and humidity. I know those subsystems might not be really related to aquaponic like fish or plants or so on, but it is not about the relation to aquaponic, it's about how aquaponic is dependent on our subsystem. Definitely the aquaponic need the power for the electronics there to work and need the water supply for the fish, of course.
For the connection, we connect the solar panel to our solar controller, which is in the box here, and we use MPPT solar controller because it have more efficiency to provide energy to the battery. So from the battery, we can provide the electricity to our electrical component.
So the special features of our MPPT solar controller, firstly, you will see that the solar panel is charging the battery, and when it is supplying to the load, let's say I want to supply to the load, okay, now it will be supplying to the load. So basically now the solar panel is not charging the battery because the battery is already full, and that's one of the main features of the solar controller. It will prevent the overcharge of the battery. Once the battery is already fully charged, then it will stop charging the battery. The other special feature that it can provide two types of output, which is 5 volt through the USB and 12 volt directly from here for the load. So how can we extend the connection? We are actually using this type of terminal where we are connecting the positive and negative load here, and other groups can connect directly their load to the terminal. And the load will be delivered to there directly.
So this is our survey tank to harvest the rainwater. That you can see on the top of this as a netting to cover the inside from the other stuff to get in, like leaf or insect or anything. So this water supply is supplying the water to the fish tank. In case it's not enough or so, it will connect with this pipe and has the solenoid valve from here. It's connect from here to here. Then this water saver tank also providing the water for our water misting.
So the main component in the water irrigation mist is our deer pump here, which is 0.8 megapascal. So basically, the water will be sucked directly from our rain harvesting tank through the water filter. So after the water is have been sucked by the pump, it will be pumped exactly to our water mist. We are using this pump, which can give 0.8 megapascal, which is strong because the mist need a strong pumping pressure to give us the best fine mist. So basically, we have designed a system with 13 nozzles to ensure that all the plants are being covered, and through our design, we ensure that there is no overlapping of the mist, because too much misting can affect the plant.
Okay, for the shade, we use 50% because we want the sunlight to go through half and half, because the plant need to have enough sunlight to grow.
Now I'm showing our solar controller and our ESP placement in the box. This is the solar controller, and that is our ESP32 that used to control our pump based on the temperature and humidity sensor by the DHT11 sensor. That is the Blink apps that we can monitoring our temperature and humidity and also control our pump. When in the manual mode, we can manual open our relay. Let's manual open the pump to spray out the water, and we can close it manually, and we also can make it by automatic mode. This automatic mode will open based on the temperature and humidity that I set based on the capture from the DHT11. And this is our DHT11 sensor to capture the humidity and temperature. We place inside the shader to make sure it can more easily to capture the temperature and humidity for the plant. The temperature and humidity value we also can see from our Blink apps, which is view online, and also from our OLED screen outside of our box.
Okay, the first of all, that what we have chosen is this type of beam, which is called painted beam. We have designed into this type of shape because in order in any strong winds or what, it will never bend and all. Second thing is it's painted, so when it exposed to heavy rainwater or any water droplets, it will never get rust. Second thing is, all for the wires that we have been using, we have used covered with PVC tube, which ensures that there's no water inputs will be running into the wire. Okay. Next, we will be talking about the water irrigation mist structure. We have came up with PVC pipe, which we have already, for the prevention method, we came up with the white tape and the glue, and also we designed with a huge diameter where we can access easily from the shade. There will be no obstacles for us to, or any injuries, because there's no sharp edges. We have polished it. Came up with a design where we came up with acoustic lining, which is a studio foam concept, which will be using this type of material to ensure that the vibration and noise which is reduced. And we have tested using free noise microphone. We have proven that there's chances and reduces of 2 decibel from the previous record. So this will be the cover, and it ensures that there's no water will be into, and the sound will be preventing from outside, which disturbing the classroom or also creating noise pollution.